Now let's look at more examples exercise on those that we have treated before. So look at this. This is example of binary operation. So A operation B is defined as this. So when A operation A operation, that operation is like star. Operation B is defined as A square plus B, and we are given 3 operation 4. That means 3 operation 4. A is representing 3, while B is representing 4. So it gives us what? 3 raised to power 2 plus 4. That is what? 9 plus 4. That is 13. That's how we have 13 here. Example 2. We are giving another operation. A operation B equals to 2A minus B. So we have to find 5 operation 1. 5 operation 1 means A is 5, B is 1. So 2 into brackets A. Our A is what? Our A is 5 minus our B is 1. So we have what? 10 minus 1. That gives us 9. I believe you get that. So let's look at another example. Make sure you copy down the examples, please. Then the next one, let's look at this. We are given operation A operation B as A plus 3B. So we are asked to find 2 operation 5 and 4 operation minus 1. That's very simple. We have been given A operation B to be A plus 3B. So 2 operation 5 will give us what? A is 2. That's 2 plus 3B. That's 3 into brackets 5. So we have what? 2 plus 15. That is 17. I've gotten the result for 2 operation 5. So you have to find this. I know some of you will say you are giving us the negative one. Okay, let me do the second negative here. But I will do this and you will do this. Now 4 operation minus 1. You know it will give us 4 plus 3 into brackets minus 1, because minus 1 is representing B. So we are going to have 4 plus 3 times minus 1. That's minus 3. So now open this bracket. Minus times plus. That is minus. So 4 minus 3 gives us 1. So that's the solution to the second one. So we are going to do this number 2 for me. Complete. So the operation we are given here is A operation B. It is defined as AB plus 2. So we are just to find 3 operation 4 and minus 2 operation 6. This is the definition we are given. A operation B is AB plus 2. So now let's look at more example on closure. For closure, look at this example. I believe you still remember what Z means. Z is an integer. So integer under X, they said is close. The example is telling us that it's close. What does that mean? When they say something is close, it means when you perform the operation on it, the result you are going to find will still be element of that set. So the one that we are having here, we have 4 times minus 7 give us minus 28. Minus 28 is still an element of integers. So before we can be given something like this, that means they have defined an operation for us. They are not just given the operation A. So probably let's say we have A operation B is equal to A times B. So that is exactly what they did here. So when you have 4 operation minus 7 to give you 4 times minus 7, that is 28. So that is 28. Minus 28, sorry. Minus 28. So minus 28 is also an element of integers. If you don't forget, you see integers are positive or negative whole numbers. They are whole numbers, but it comprises of both negative and positive. So minus 28 is still an element of integers. So that's why it is closed. It is closed when the result you find is in that set. Then natural numbers under division is not closed. What does that mean? Let's say you have A operation B is equal to A divided by B. So, and you know natural numbers start from what? Start from 1, 2, 3, 4, and so on, and they are all positive. So let's just pick 2 natural numbers. So that is what they did here. We have 3 what? Operation 2. That will give us 3 over 2. What is 3 over 2? 3 over 2 is one whole number, 1 over 2. Or let's say we have 1.5. So 1.5 is a positive number, but it's not a natural number. The reason why it is not a natural number is because it's a decimal. It's not a whole number. So 1.5 is not an element. Whenever you see me cancelling E like this, that means it's not an element of natural numbers. So that's why it is not close. Assuming this is an element of this one now, it will be close. So division is not close for natural numbers. So the exercise for you, you have to check. You can still use the operation that I used in the former slide to test all this. You should test whether all these ones are close, whether integers are close under subtraction, whether irrational numbers are close under addition, whether natural numbers are close under multiplication, even number under addition is even number close under addition. That means if you add two even numbers together, will you still get even numbers? So if you can still get even number, that means it is close. If you multiply two natural numbers together, will you still get result that will be natural number? If you get that, that means it is close. For irrational numbers, for rational numbers, that is fraction. When you add two fractions together, you still get fraction in all cases. And for z, we subtract two integers from another, one integer from another integer, we still get a result that will be an integer. So I want you to try as much as possible to lay your hands on these topics, and you can as well go to the internet and search more on the topics. But I believe I've done justice to the topic. Now let's look at commutativity. You know, commutativity is when A operation B is equal to B operation A. So if you can achieve that with this given operation, then it is commutative. So look at this. A operation B is A plus 2B. We said not commutative. It's like we have done this type of example before. Yes, we have done this type of example before. When I wrote this thing for you, that's A operation B is equal to A plus 2B. We use it under distribution and a distributive property. So let me use it for commutative for you to see that it is not commutative. So for it to be commutative, A operation B must be equal to B operation A. And what is A operation B? A operation B is A plus 2 what? 2B. So what will now be B operation A? Don't forget that they have changed position. So our A now is B here. So that means B plus our B here is A. B is A. Then A is B. So that's B plus 2 what? Our A is now B. Don't forget 2A. Now if you look at these two, I did the same. A plus 2B and B plus 2A. If you put any number here as a value of A and any number as a value of B, can we get the same results? No. Because this is A plus 2B. This one is B plus 2A. So we have checked that one. They are not commutative because they are not the same. So multiplication on integers. Multiplication on integers, they are commutative. What this one is telling you that if you pick any two integers and you multiply them together, you will still get an integer back. Let's say our A operation B is A times B. So just think of any integers. Let me take minus 2 operation 13. That is minus 2 times 13. What is minus 2 times 13? That's what? Minus 26. So 26 minus 26 is still an element of integers. If you don't forget the definition of integers, integers are positive or negative whole number. So here is a negative whole number. is still an element of integers. Let's move to the next slide. It's still on commutative. Please try and do justice to these questions. Try and do justice to them. So you should determine whether they are commutative. A operation B is equal to A minus B. So you check whether it is commutative. Whether A operation B is equal to B operation A. Whether A operation B here is equal to B operation A. Whether A operation B is equal to B operation A. So the one that is commutative, you write commutative. The one that is not, you write it is not. Associative. They say under addition, associative. Okay, there is associative under addition, but there is no associative under subtraction. What that means is when you have 2 plus 3 plus 4. If you group this together like this, you have 2 plus 3 plus 4. It's still the same thing as 2 plus, when you group 3 plus 4. This is 5 plus 4. And this is what? 2 plus 7. We have done that before too. 9 equals to 9. So under addition, it is associative. But for subtraction, let's say you have 2 minus 3 minus 4. I take these first two together to have 2 minus 3 minus 4 will be equal to 2 minus 3 minus 4. Cannot give us the same thing, because this one will give me 2 minus 3, 1 minus 4. And this one will give me 2 minus 3 minus 4 minus 1. So 1 minus 4 gives me minus 3. Is it equal to 2 plus 1? So minus 3 is not equal to 3. Never. So that is associative. Copy that. Then that's associative. Then for distributive, we have solved more example on that. On identity elements. Identity element is a number that you multiply by another number to get that number again. While inverse is a number that you add to another number to get an identity element. So A operation B is A plus B minus 1. So the identity element is equal to 1. Multiplicative identity is equal to 1. We have talked about that one before too. So for multiplication, the identity element is 1. For addition, the identity element is 0. So it is identity for identity. Element identity. So work on these examples. On this exercise, the inverse. Work on inverse too. Inverse is the number that you add to another number and you get this inverse. When you have A, you have A multiplied by B. So this B is an inverse if the product you have is E. Identity element.